Hi students, so let us discuss one more important part in this chapter is that is what it is derivation of final velocities in case of inelastic collisions in the center of mass frame of reference. So already I have told it is what is your center of mass, what it means. Whenever that system consisting of what is n number of particles. In such cases, it is difficult to specify the velocities of individual particles. So for this purpose, so we are considering and what the point, one point where the entire mass of that system is concentrated. So that point we are calling it by what it is, the center of mass of that system. So here, what is a center of mass, a frame of reference? If the inertial frame of reference is fixed with the center of mass of an isolated system, then the center of mass is at rest with respect to this frame. What it is? If the inertial frame of reference is fixed with your what? The center of mass of an isolated system, then the center of mass of that system is at rest with respect to the inertial frame of reference. In when that the center of mass of an system is at rest with respect to the frame, then VCM is equals to 0, then automatically P of CM equals to 0. So this frame of reference so is called as what? The center of mass of frame of reference. So see here. So here I have considered and what it is. One system consisting of two particles M1 and M2. So inside this one point we have considered where that the entire mass of the system is what? Concentrated. So that point we are calling it what? Center of mass of the system. Say what is your center of mass frame of reference? Here, whatever that x, y and z is there, this is my what? The inertial frame of reference. So this is fixed with what? The center of mass of this your isolated system. Then this center of when this inertial frame is fixed with what? The center of mass of this your isolated system, then this VCM, that means the center of mass of the system is at what? Is at rest with respect to this frame. Is at what? Is rest? Is rest? It is at what? Rest. With what? This frame of reference, the initial frame of reference. When it is at rest with respect to this frame, then VCM is equals to what? 0. So the velocity of center of mass of this system is what is 0, then PCM is equals to what is 0. So this frame of reference, we are calling it by what? Center of mass of frame of reference. Okay. So here, in case of your center of mass frame of reference, is the one whereby its positions, whatever its positions is there and velocities is there, are all measured with respect to what? The center of mass of this system itself is. Whatever the center of mass frame is the frame where that your what? The position and velocities are measured with respect to what? The center of mass of the system. Whatever the variables that you are measuring, those variables are measuring with respect to what? The center of mass of the system. That's why, so it is called it as what? The center of mass frame of references. Okay. So in such case, so that's already I have mentioned that R1 is the position of your positional vector of your particles M1, and R2 is the positional vector of your what? Second particle M2. And the capital RCM indicates or specifies what? The positional vector of your what? The center of mass of the system with respect to this your reference point fixed to your inertial frame of reference. So therefore, the positional vector of the center of mass of this system having two particles is given by RCM is equals to m1 v1 plus m2 m1 r1 plus m2 r2, so divided by what is the total mass of the system m1 plus m2. So when you differentiate this one, so you will get for n particles, n number of particles. If your system consisting of what? N number of particles, then V of Cm is equals to summation of k equals to 1 to what? N, Mn, Vn divided by what? M. That M is equals to, capital M is equals to what? M1 plus M2 plus M3 and so on. Okay. So therefore, this is part two, the system consisting of what? Two particles, but when you differentiate this one, you are getting what? This dRCM will be dt, which is nothing but what? VCM. VCM is equals to here, you are getting what? You are having what? Two particles. So the summation of k equals to 1 to what? Two particles. You can write Mn into what? Vn. So here is what? dR1 divided by dt, that will be what? V1. This is dR2 divided by dt, that will be what? Second part of V2 is. Okay. So this is the velocity of center of mass when the system consisting of what? N number of particles. So in the what denominators, so we are having capital M. That's M is capital M is equal to M1 plus M2 and so on. The total mass of the system is. Okay. So we know that the center of mass, that's already I have mentioned, that's the point at which the entire mass of all the particle is what is concentrated is called as center of mass. Then the system consists of n number of particles having masses m1, m2 and m3 and so on, and r1, r2 and r3 is the distance of those particles from the fixed points, that's the void. Okay. So let us write what is the initial, what is the final velocity of that particles, that those particles in case of the center of mass of the system is. So here, when no external force is applied, the velocity of center of mass of two particles of system in that either what in that system is given by VCM is equals to, so you are getting what, m1 u1 plus m2 u2 divided by what, m1 plus m2. At what time it is? Whenever no external force is acting on that system, then the center of mass of those two particles of a system is given by what is V of Cm is equals to m1 u1 plus m2 u2 divided by what, m1 plus m2. So here that here m2 is at rest, the ut is equals to 0. The velocity of the center of mass in the laboratory frame is given by Vcm is equals to what it is. You are getting here Vcm is equals to m1 u1 divided by m1 plus m2. So it indicates what? In other words, the center of mass frame of reference moves with respect to the what is laboratory what is frame with velocity Vcm. So that's not inserted here. What it indicates, so when m1, m2 is equals to, at m2 is at rest, that is u2 is equal to 0, the velocity of the center of mass in the laboratory frame is given by Vcm is equals to m1 u1 divided by m1 plus m2. That's already I have mentioned in the previous classes. So that indicates what? In the center of mass frame of reference, that means the center of mass frame of reference moves with respect to the what? Laboratory frame with the velocity of what is Vcm. So whatever that equation you are getting, Vcm is equals to m1 u1 divided by m1 plus m2, that indicates that the center of mass of frame of reference moves with respect to the what? The laboratory frame with a velocity of what is of Vcm. So that's the significance of what? That equation is Vcm is equal to m1 u1 divided by what? m1 plus m2. Now let us write u1 dash and u2 dash be the initial velocity of what? Mass m1 and m2 it is. So in the center of mass frame, then what is the initial velocity of that part? So u1 is equals to u1 dash is equals to u1 minus of v0. So u1 is the velocity of the first particle in the laboratory frame. So that goes to what? M2. Now what means at the value of VCM. So after simplifications, you are getting what is M2 U1 divided by this M1 plus what is IM2. Okay. So similarly, we would write what is the velocity of the second particle. So that equals to U2 dash equals to U1 minus of is what? Resium. So here the second particles in the laboratory frame of reference is at rest. So it's UT is equals to 0 when you're getting what? Minus of resium. After collisions, so those two particles sticks together. Hence, the final velocity in the center of mass frame is what? 0. The distant particles are at what? Rest in the center of mass frame of what is reference. What is that U2 dash is equals to what? We are getting minus of VCM. That indicates in what? The stuck particles are at rest in the center of your what mass frame of reference. Okay. Uh, so that's the significance of your these two equations. So you are getting U2 dash equals to minus of this what? VCM. What after a collision it's the two particles combined together are coalesces into a single mass. So that indicates the final velocity in the center of mass of frame of reference is 0. The distant particles are at rest in the center of mass of frame of reference. So that's the meaning of what? These equations. Okay. So thank you.